New Deep Dive.
Could we really be seeing humanoid robots, serving us dinner or building our next car in just a few years?
Good question, right?
Or are those really big promises from tech giants like Tesla maybe more of a futuristic dream that's hitting some very real walls?
Yeah, the reality check seems to be coming.
Today, we're pulling back the curtain on Tesla's really ambitious Optimus robot project. I mean, Elon Musk certainly painted this vivid picture. Thousands, maybe millions, of these robots in factories, even our homes.
That was the vision, absolutely. Very bold.
So our goal today is to really explore exactly where this, revolutionary project stands now, mid-2025.
And there's a lot to unpack there.
We'll uncover the considerable challenges it's facing and try to understand why we're hearing more critical voices now. This isn't just about the tech. It's, a fascinating look at that clash between a grand vision and the tough realities of engineering in the market.
Exactly. Vision versus execution.
You'll hear about everything from, unexpected technical glitches to big management shakeups and the financial pressures that have really come to light. So, okay, let's set the stage. Let's start with the vision that got everyone talking.
Right. Back in 2022.
Yeah, back in March 2022, Elon Musk announced that within several years, thousands of Optimus robots would be working on Tesla's production lines.
Thousands. That was a number.
He really put it out there, didn't he? Declaring these automated systems would be a new pillar for Tesla, right alongside EVs and autonomous driving tech.
Standing shoulder to shoulder with the cars.
And then by late 2022, we saw those first working prototypes, public demos, basic movements.
Yeah, I remember those. They definitely sparked curiosity.
Sparked a lot of curiosity and, huge hoax among investors, enthusiasts. And Musk's targets were just incredibly ambitious.
Understatement, maybe.
He declared, what was it, by the end of 2025, 5 to 10,000 robots annually.
5 to 10,000 per year.
With an eye to scaling up to 1 million units within 5 years. 1 million. From your perspective, watching robotics closely, how did those numbers hit you then?
Well, that initial surge of optimism, it pretty quickly ran headlong into the complexities of reality, didn't it?
It seems so.
While the vision was, undeniably compelling, what struck me right away was just the sheer scale of the challenges involved. Technologically, organizationally, to actually make that vision happen at that speed. The gap between that aspiration and the practical engineering hurdles, it just proved far wider than I think many people anticipated.
And as we got into 2025, that reality really started to, diverge from the plan.
Yeah, things started to shift.
So what were the critical points? What really happened, and what did it show about where the project actually stood?
Well, the reports are pretty clear now.
Yeah, the latest industry reports clearly show that since mid-June 2025, Optimus production has been completely halted.
Halted. For at least 2 months.
At least 2 months, and some sources suggest it could be much longer. Only a few hundred fully completed robots actually made it off the line.
Just a few hundred compared to those targets.
And on top of that, Tesla's launched this extensive redesign phase for key robot parts.
Back to the drawing board on some things.
Exactly. And there's no clear timeline, no clear scope for when that will even be finished. Now let's dive into the technical stuff, the nitty-gritty.
This is where it gets really tricky.
The biggest obstacle, it seems, by far, has been developing robot hands and forearms that are, dexterous enough.
The dexterity problem, it's classic robotics.
We've learned that by the end of May this year, Tesla had produced nearly 1,000 robot units. They even got parts for about 1,200 more.
So the bodies are coming along, sort of.
But here's the bottleneck. Producing those crucial hand and forearm bits, it lagged way behind everything else.
Ah, the hands. Always the hands.
So you've got dozens, maybe hundreds of partially assembled robots just sitting there, idling in factories, waiting for new parts that are still being designed.
Wow. That's a production nightmare.
And the challenge with the hands isn't just movement, right? It's durability, load capacity for tough jobs, but also that fine motor control.
It's an incredibly difficult engineering problem. I mean, imagine trying to design one thing that can grip heavy parts and handle something delicate
like an egg. Yeah.
Exactly, without crushing it. That's the kind of, multifaceted dilemma they're facing.
It explains why it's described as slow and painstaking work.
Absolutely. You're talking material science, advanced robotics, micro actuators, all converging in this one tiny, complex part. It's tough.
Right. And that's not all. Other critical hardware problems popped up too.
Like what?
like joint motors overheating during use and transmission systems wearing out way too early under industrial conditions.
So reliability issues under real-world stress. That makes sense. Those demos are one thing, but factory work is grueling.
And maybe the most telling public moment, that demonstration at Tesla's new restaurant on Hollywood Boulevard.
Ah, yes, the popcorn incident.
The popcorn incident. An Optimus robot, operated by a human remotely, was supposed to serve popcorn,
Supposed to?
but it lost connection, froze up, couldn't finish the task. Reporters there called it clear proof the tech isn't ready.
Ouch. Public demos are high stakes.
You can almost hear the collective gasp, right? And you know the PR team were scrambling. It's just such a public reminder that the lab is one thing.
And the unpredictable real world is completely different. It's fascinating because it's not just a glitch. It points to a fundamental bottleneck in AI and robotics.
Oh, so?
We can build strong machines, sure. But the real challenge, it's the chaos, the unstructured nature of the real world. The weight of popcorn isn't always the same. The lighting changes. People move unexpectedly.
Right. It's not a controlled factory environment.
Exactly. This isn't just programming a robot for one task. It's about building systems that can learn true adaptability, common sense, really, in real time. And that is orders of magnitude harder than typical industrial automation.
And Tesla hasn't really hidden the fact that right now Optimus robots are like not even half as efficient as an average human worker, even for simple stuff like moving batteries.
Half as efficient. That's not great for justifying the investment yet.
And that's down to those mechanical flaws we mentioned and also limited battery endurance.
Battery life is always a huge factor in mobile robotics.
Now, the complex AI control algorithms, they're still in early training stages, mostly using synthetic, virtually generated data.
Simulations, basically.
Right, computer simulations, not tons of real-world experience yet. The hope is that this synthetic data will speed up improvements and cut down errors later on.
It's a common approach, using simulations to bootstrap learning, but eventually you need that real-world interaction to fine-tune it.
So we've seen the sheer engineering complexity, huge hurdles. But like often happens with these big projects.
It's rarely just the tech.
Exactly. These technical problems weren't the only challenges. We've also seen significant management changes, especially key leaders leaving, which seems to have compounded the problems.
That can definitely slow things down.
Yeah, in June 2025, Milan Kovac, a key manager who'd led the Optimus program since 2016, Tesla's senior VP of robotics and automation, he left.
Wow. Since 2016, that's deep institutional knowledge walking out the door.
Right. And his departure, just months after his latest promotion, was widely seen as a true management crisis. In fact, 5 top executives have left in just the last 6 months.
5. That's a significant number.
Including Omid Afshar, who oversaw manufacturing in North America and Europe. From your perspective, how badly does that kind of instability hit a project like Optimus, especially when they're trying to redesign critical parts?
Oh, it's absolutely critical. I mean, when you have a visionary project like Optimus, pushing boundaries in engineering and AI, you need stable, experienced leadership. It's paramount.
These aren't just managers, right?
No, they're often the architects of the core vision. They understand the nuances, the trade-offs, the technical paths. Losing key people like Kovac, that creates huge vacuums.
How does that manifest?
It can slow down decisions, disrupt the redesign efforts you mentioned, even hit team morale pretty hard, and then you layer on legal disputes.
Like the lawsuit Tesla filed?
Exactly. Alleging theft of trade secrets related to robot hand production. It just highlights how much management stability and protecting your IP are tied to keeping momentum, especially in these super cutting-edge fields.
And currently, the management responsibility for Optimus, it's fallen to Ashok Ellaswamy.
The head of the full self-driving project.
Yeah, so he's now facing this huge challenge, fix the tech and navigate what looks like a deepening personnel crisis.
That's a tough position to be in, juggling 2 massive high-pressure projects.
Let's also look at Tesla's financials, because that's deeply tied into the Optimus program's pace, isn't it?
For sure. Money talks, especially when projects get delayed.
And in 2025, Tesla is facing, well, its biggest crisis in over a decade, some are saying.
The car market has been tough.
In Q2, the company reported a 12% drop in overall revenue and a 16% decline in EV sales. That definitely spooked investors.
Those are significant drops.
During the earnings call, Elon Musk admitted openly a few rough quarters ahead. He mentioned the phasing out of U.S. government EV incentives.
Yeah, that's a factor.
Investor sentiment after that call was described as especially grim. Analysts said they had never heard Musk sound so, well, somber.
A change in tone, definitely noted by the market.
And it had immediate effects. Tesla's share price dropped 9% the day after those results came out.
Ouch.
So, with car sales weakening, Musk has tried to shift the focus, talk up autonomous vehicles, talk up robotics.
The future potential.
But his recent comments about the Optimus timeline and scale, they've become much more cautious than a year ago.
Pulling back on the big promises.
Yeah, he's no longer promising 5 or 10,000 units by the end of 2025.
That target's gone quiet.
And that goal of 1 million units a year within 5 years, he now calls it merely a reasonable aspiration, not a hard commitment.
Aspiration versus commitment. That's a very telling shift in language.
So as a result, those original bold plans, formally postponed, the redesigned Optimus Model 3 is pushed back to early 2026 at the earliest.
At the earliest. So potentially later. This really shows how financial pressures and investor feelings can directly shape the public story and the timelines for even these huge tech projects.
Totally.
When the main business hits headwinds and the market gets skeptical, it forces a recalibration. You have to manage expectations. It's a stark reminder that even a visionary like Musk has to operate within market realities.
So wrapping this up, what does all this mean for the future of humanoid robots, for Tesla's grand ambitions?
It's a pivotal moment for sure.
To sum it up, it seems like today the Optimus project is this, hugely ambitious idea that's hit the concrete wall of technological and market constraints.
And maybe hit it earlier than even skeptics thought.
What was supposed to be a symbol of Tesla's innovative edge has kind of exposed the frailties of project management, communication issues, and just the sheer scale of challenges facing the whole robotics sector.
It's a tough field. Progress is often slower than hoped.
And the Optimus story really stands as a warning, maybe, to other companies thinking about a robotic revolution soon.
A cautionary tale, perhaps.
It shows this stuff requires enormous capital, yes, but also massive patience and just meticulous, painstaking engineering.
You can't just throw money at it and expect instant results.
Which brings us to a final provocative thought for you listening. Is the world truly ready for humanoid robots? In our factories, shops, homes, on a mass scale.
And are we perhaps overestimating what current AI and automation can actually do? The Tesla example really shows that even a giant like them with immense resources isn't immune to basic mechanical problems, battery limits, software errors.
Right.
It highlights that putting these complex systems into unpredictable real-world places is just a much bigger challenge than many might assume.
On the other hand, though, and this is important, it's often these kinds of spectacular setbacks that become the seed for major breakthroughs, isn't it?
That's very true. Failure is often part of the process in innovation.
Without bold experiments, without trying and failing and trying again, there's really no progress.
Absolutely. It's certainly possible that this period of pausing, revising, taking a strategic step back, it might actually enable Tesla to overcome these hurdles.
Learn the lessons.
Exactly. Learn the hard lessons. Future years could still bring the kind of breakthrough the auto and tech sectors are hoping for, maybe even propelled by these challenges.
It's a really fascinating saga, and we'll definitely be keeping a close eye on it for you. Keep tracking the developments. There's always more to learn and discover in the world of tech.
Subscribe. New Deep Dive. Subscribe. New Deep Dive.